starting this next section in chapter 13, 13.2 as volumes of pyramids and cones. We are going to break this up into 2 days. Today we're just going to be doing with volumes of pyramids. Next section will be volumes of cones. Anyway, same type of concept. We need to know the area of the base, and we'll multiply that with the height, except with pyramids and cones, we will divide those by 3. Get the area of the base, multiply that to the height, and divide it by 3 for pyramids and cones. I have a couple examples. We'll get started with those. On first one, the base is rectangular. There's a rectangle, so we got a rectangular pyramid. Second one, the base is a triangle. It looks like it's a unique triangle that has a right angle. There's an example. I want to do an example of one of these because there's one of these that's in your assignment. I'll get started with the first one. We'll get to calculate the area of the base, and then we'll multiply that to the height, and we'll divide it by 3. So formula for pyramids and cones. Volume equals area of the base times the height divided by 3. Wish I could see you in person because I actually have an experiment to show you why we ended up dividing these by 3. Anyway, volume for pyramid and cones. Area of the base times the height divided by 3. Again, it's critical to know what you're doing as far as where your base is, as far as calculating an area of that. Secondly, it's important to know that you need to use the height of the pyramid or the height of the cone, which we will be going over in the next section. But height of these, I've got them already highlighted. It's not the slant height. The height is going to go from the middle, from this vertex up here, so it forms a right angle with the base. All right, we'll calculate the volume of this first one. So our base equals, it's a rectangle, 6 times 8, which is 48. Area of the base is going to be 48 meters squared. And then we'll take the area of the base times the height and divide it by 3 to get your volume. Times the height, 12. And then divide it by 3. 48 times 12 divided by 3. Which we have 192. So we're looking at 192 meters cubed. Volume is in cubed. 192 meters cubed. All right. All right, we'll start here. Now we've got this person. We'll start here with the second one. I made it a little bit more challenging. This is actually just an example of one that's just like on your homework assignment. You need to calculate the area of this base. It's a triangle. And then we have the height, which is 14. And know which dimensions that you use because, I mean, you got to manipulate those in the right order. It's going to be, for this triangle, it's just the length times the height of the triangle. The length is 10. The height on this is x. We don't know what it is, but it's a right angle, so we can use Pythagorean theorem to figure out what x is. 12 is just an hypotenuse for that base triangle. So we'll use Pythagorean theorem to calculate what x is so we can get the area of the base. All right, and that is 10 squared plus x squared equals 12 squared. So 100 plus x squared equals 144. Subtract 100 from 144. You got x squared equals 44. Take the square root of 44. So So you're looking at around 6.5. 44 square roots. 6.6. I needed 6.6 to calculate the area of the base. So then we have our base. It's 10 times 6.6 divided by 2. 10 times 6.6 is 66, divided by 2, 33. So our base is 33, those are meters squared. Area of the base, 33 meters squared. Multiply that to the height, 144, and then we will divide it by 3 to calculate our volume for this pyramid. So volume equals our base, 33, times the height, 14, divided by 3. 11 times 154. Volume of that pyramid, 154 meters cubed. So again, I got to say, for calculating volume with these pyramids, cones, whatever they are, rectangular prisms, you need to calculate the area of the base. On cones and pyramids, divide that by 3. So area of the base times the heights divided by 3.